Have another application of properties of, or we're going to be applying the properties of a definite integral. And I wrote here the three properties that we're going to be using in this case. So we should know these three properties uh, in general. These are three of a few, but these are the three that we need to know. So just briefly reviewing what each one of these three things says. The integral of a sum or difference is the sum of the integrals or the difference of the integrals. So I should put plus or minus. I didn't put the minus, but I put plus or minus here. So it just says that I could split the integral along a plus or a minus. Okay, then number two. Number two says that I could factor outside the integral constant terms. So if it's the integral of 4 times f of x dx, that's just equal to 4 times the integral of f of x dx. And then the last one we've gone through a few times, I think. It just basically says that if we swap the bounds of integration, the limits of integration, if I put a on the top and b on the bottom, this just gives me a negative sign. So it just becomes the relationship between these two is that it's the negative of the other. Okay. Now let's use these properties to answer this question. So we first are given something that, I'm not too sure exactly how to get what it is that we need here, but let's go through what we have. So starting off, I see this immediately, right? And I see that there's properties of the definite integral that I could apply here. So let's go through those properties. So I'm going to first just rewrite this first one, right? 3 g of x plus 2 dx. And I know that this value in this case is 35. Now, let's see how I could change the way this looks. Well, I could apply property 1, right? Or what I'm calling property 1 for the time being. But I could write it as the sum of two integrals. I could write it as the integral from negative 2 to 8 of 3 times g of x. That's the first term. Plus the integral from negative 2 to 8 of just 2 dx. And we'll deal with this one here, this term, in a second. And we know still that that has to be equal to 35. Now, from property 2, I could take out this 3, and I could write it as 3 times the integral from negative 2 to 8 of g of x. I should have put the dx here, I apologize, dx. G of x dx plus, and I'll start working with this here, and I'll give you why we're going to be able to find this right away. If we remember, right, our interpretation, we have negative 2 here, and then 8 over here. The integral could be interpreted as the area beneath the integrand, which is 2 in this case. That's the integrand in this case. And the function 2, well, that just looks like a horizontal line at y equals 2. So if I'm looking for the integral of 2 from negative 2 to 8, well, that's just exactly whatever the area of this rectangle is. And that's not too hard to find because I know that this length is 10 and the height is 2. So I know that this whole integral here is 2 times 10, which is 20. And then that I know equals 35. Now, if I look over here, right, I know that maybe now, right, I can actually solve for what this value is. Because that's the only thing that's missing in this equation, and that might help me find out what it is that they're asking, which is this value, and it will. Because now I know that if I minus 20 on both sides of this equation, I'll get 15 is equal to, and this is what I want this piece right here, right? So 3 times this piece, I don't know, whatever you want to call it, you want to call it star, that entire integral, 3 times this entire integral, whatever it is, 3 times star is equal to 15, right? 3 times star is equal to 15. That implies star is 5, right? When I divide by 3 on both sides. And star, I just called the integral from -2 to 8 of g of x dx is equal to 5. And this is going to help me out a lot now, because now if I look at the other information that they gave me, right, the integral from 5 to -2 of g of x dx is -12. So that implies that, let's write this over here, that implies that the integral from -2 to 5 of g of x dx, and I swapped the limits of integration, right? I put the -2 on the bottom and then the 5 on the top. That flips the sign of this integral, so that way I get 12 for this value. And then I know from 5 to 8, and I'm looking for what 5 to 8 is, so I should know now that I could write, let's see what I have here. I know that the integral from, oh, I needed another rule. You see that? 4. What's rule 4 say? The integral from a to b of f of x dx. And this is a good one to go through. From b to c of f of x dx, what do we think it is? It's the entire integral from a to c. And I need to use this fact to end here to get my final equation. So from -2 to 8, let's say, okay, let's write it in the direction that I have it here. So from -2 to 5 of g of x dx plus from 5 to 8 g of x dx equals from -2 to 8 of g of x dx. Now I know what all these pieces are except for one. I know this here, right? I just found that out. That's 5. So this is 5. So I'm going to rewrite the equation over here. 5 equals. This is what I'm looking for, whatever you want to call that. Let's call that, I don't know, let's call this circle filled in, or X or Z or whatever. That's what I'm looking for. I'm calling this circle. Okay? And then this here, I know is 12. So 12 plus whatever the circle is equals 5. I can solve for the circle by minusing 12 on both sides. And I get that the circle, that integral that I'm looking for, is -7. And then that is my answer right here. And you could have called that integral whatever you want. I could have just left it as the integral, but I don't like writing it over and over again, so I just called it whatever. I called it a circle. Same way I called this integral at one point, I called it a star. But you could have called it whatever you like, or you could have left it as an integral. It's up to you. But this one really does illustrate a lot of the properties of a definite integral and how you apply those properties. So I definitely recommend going through this one again and again. You could even maybe like come up with your own one. Maybe if you're clever, you could do like 4 times g of x plus 3, get some value. It might be a fractional value, but that's fine in any case.